I would like to welcome everyone to today's webinar, Durable Construction with Preservative-Treated Wood. My name is Marcy Weber, and I'll be the education team moderator for today's presentation. Today's webinar is going to run 1 hour. We have a great guest speaker from WWPI to discuss preservative-treated wood, so hang on to your seats for today. American Wood Council is a registered provider with the American Institute of Architects continuing education credits or education systems. Please note that this webinar and associated slides should not be used as a substitute for competent engineering support and expertise. This course is copyrighted and not eligible for reproduction. And here's the team that is providing this course for you today. Our speaker today is Mr. Butch Bernhardt, Deputy Director of Western Wood Preservers Institute in Vancouver, Washington. Butch has 3 decades of experience providing support and education on preserved wood products. Our engineering moderator is Director of Educational Outreach, Lori Cook, and behind the scenes is our Education Administrator, Kim Paulson, and myself, Manager of Education and Accreditation, Marcy Weber. So now let me give you over to Butch to discuss preservative wood treatment.
Hello and welcome to our webinar, Durable Construction with Preservative-Treated Wood. We'd like to thank the American Wood Council for the opportunity to present this program to you today. My name is Butch Bernhardt, and I'll be your instructor for this course. I am the Deputy Director for Western Wood Preservers Institute based in Vancouver, Washington. For more than 75 years, we've represented the wood treating industry in 17 Western states and 2 Canadian provinces. So let's start by reviewing what we'll cover within this next hour. In this course, you'll see how preserved wood is made and used in construction today. We'll also talk about the quality control that goes into making preservative-treated products. You'll also learn how to properly specify preserved wood products under the use category system that was developed by the American Wood Protection Association. We'll explore the many references in the building codes regarding where and how to use preservative-treated wood. And you'll also see how to use the industry's best management practices when using preserved wood in aquatic and sensitive environments. So let me introduce you to preservative-treated wood. Now, of course, everyone likes wood. I mean, what's not to like? Wood is the original, sustainable, environmentally friendly building material. Now, wood is created by taking some basic natural inputs, and in a few decades, it becomes a tree that not only can be converted into an amazing building product, but the process also generates many other benefits for our environment. Now, we enhance this cycle of sustainability when we pressure treat wood to protect it against deterioration. With treating, we can make wood last for many decades, enough time to where a new tree can be grown to become a replacement product once the preserved wood has reached the end of its service life. So, how did we get preservative-treated wood? Well, let's jump into our time machine to find out. About 180 years ago, there was an English lawyer named John Bethel. Now, he was bored by practicing law, so he decided to try his hand at inventing, which led him to look at a maritime problem: how to keep the timbers in sailing ships from rotting. Now, after trying a number of methods, Bethel found success with a process to impregnate wood with a new distillation called creosote. About 3 decades later, a New Yorker named Lewis Robbins came across Bethel's work. He believed it could help meet the emerging infrastructure needs in America, and he confidently predicted that the newly patented Robbins process would, quote, arrest the universal process of decay. This would not only save millions of dollars in replacement costs, but also conserve the country's forests. Now let's fast forward today, where here in the 21st century, preservative-treated wood remains a central part of our infrastructure. Thousands of miles of rails rest on preservative-treated wood ties. As many as 150 million preserved wood poles carry electricity and communications to every corner of North America. Ports and marinas are supported by treated pilings, while preserved wood bridges and guardrails ensure the safe movement of vehicles and pedestrians. Preserved wood is also found closer to home in decks and outdoor structures, as well as in commercial buildings, industrial warehouses, boardwalks, and a variety of other applications where the wood is exposed to the elements. Now, despite this wide use, preserved wood is often dismissed for being too primitive, too much maintenance, or too dangerous for the environment. However, the real story of preserved wood today is far different than these perceptions. Trees are made to grow and die and then break down into organic material so the cycle can continue. But we're not too keen on this cycle if we've turned that tree into a wood product. Whatever we build out of wood, we want it to last. However, nature has other ideas and seeks to return the wood to the earth no matter where it's at. When we turn a tree into a building product, it can still attract a host of organisms dedicated to breaking the fiber down. Wood is at risk from insects that deteriorate wood by eating it and making homes in it. Insects that pose the highest risk include termites, carpenter ants, and wood-boring beetles. Each year, these insects cause an estimated $5 billion in damage to wood structures. Decay fungi is probably the biggest threat, and it's the most ubiquitous. Fungal spores are everywhere. In fact, we're probably breathing fungal spores as we speak. Now, for decay fungi to break down wood, they need these four things: food, which is the wood itself, suitable temperatures, moisture, and oxygen. Now, when it comes to protection, our choices are pretty limited in terms of protecting that wood, particularly when it's used in an exposed outdoor application. We can't really change the temperature. We can't change the moisture because we can't change the weather. And we can't change the oxygen. So that leaves us with one thing that we can change, and that's the food or the wood. Pressure treating changes the wood by creating a protective shell of preservatives integrated into the wood fiber itself. Now, this is a passive protection. It only affects those organisms when they try to attack the wood. And we use wood's natural structures to create this barrier. If you were to look at wood fiber through a microscope, you'll find it looks very similar to a collection of straws with openings at the ends and along the length of these tubes. In nature, these tubes and openings carry water and nutrients from the roots through the entire length of the tree. Now, for pressure treating, we use these natural structures to integrate the preservative into the wood. Let's take a look now at how we place that protective barrier into the wood. Efforts to protect wood from deterioration are as old as civilization itself, with records about wood preservation dating back to ancient Greece, Egypt, and Rome. Here in the United States, commercial pressure treating really began in the mid-1800s, focusing on extending the service life of infrastructure products, such as rail ties, utility poles, bridge timbers, and marine pilings. The process itself of treating wood is relatively simple, and while the technology has advanced over the years, we do basically the same thing they did 180 years ago. We use pressure to integrate preservatives into the fiber of the wood. Other than rail ties, most wood that is treated is softwood, and it is treated within the regions where the respective tree species grow. In the West, the species most commonly treated are Douglas fir and hemfir. You may also find treated ponderosa and lodgepole pine as well. In the South, the species most often used in treating is southern yellow pine. In the Lake States in the East, red pine is treated, as well as many different varieties of hardwoods, which are typically treated for use as rail ties. For wood used in construction, the treating process starts with procuring sawn lumber and plywood, which is purchased directly from sawmills and plywood plants. There isn't really a lot of integration between the primary manufacturers and treaters. They're in most cases separate companies and separate processes. To prepare wood for treating, lumber and timbers are often resorted and trimmed at the treating plant. Many treaters may also stain the lumber prior to treatment to create a uniform color in the wood. That's particularly true here in the West, where a lot of our treaters, almost all of our treaters, stain it to a different shades of brown to help give an even look to those products. As part of the preparation for Western species, Douglas fir and hemfir, that are going to be treated for a ground contact application, which is the highest risk use, the wood is incised prior to treating, with small incisions made in all sides of the wood. Now, these incisions allow the preservative to move deep into the wood to meet industry standards for penetration. Southern yellow pine does not require incising, and it's the difference between the makeup of the species. Western species like Douglas fir and hemfir are what are considered refractory species, and they have a thin sapwood, which is what you treat when you do pressure treating. Southern pine is considered a thick sapwood species with a lot more sapwood, so it can accept the treating much more readily. Now, while there are a variety of preservatives used today, the manufacturing process is virtually the same for all. And in fact, this process is also used to treat wood with fire retardants. Now, the treating process starts with untreated wood loaded onto carts and moved into a specially made pressure cylinder called a retort. Now, the retort, which can be up to 150 feet in length, is sealed and a vacuum is applied to remove the air. Next, the liquid preservative is pumped from storage tanks and completely fills the retort. Pressure is then continuously applied to the retort to force the preservative into the cells of the wood. Now, the processing time for this process can vary depending on the wood species, the size and the type of wood product that's being treated, the preservative used, and the application of the wood product in its end use. For example, if you're going to be treating it for an above ground application versus a ground contact application. At the end of the pressure cycle, the preservative solution is drained from the retort and a vacuum is applied to return the excess solution to storage tanks for future use. The preservative wood is moved out of the retort onto a sealed drip pad to reclaim any residual preservative that may be remaining on the surface of the wood. Representative core samples are taken and analyzed to ensure that quality and durability standards are met. Third-party inspection agencies also take core samples during regular visits to confirm the plant's quality control. The finished preserved products are then moved to the plant's storage area for shipping, where the units of wood may be covered with a top wrap and moved to the marketplace by truck, rail, or barge. Let's now review the preservatives that are used today for wood products. Now, few people have any issues with the whole treating process, but where they may have concerns, though, is in what is being integrated into the wood. Preservatives are chemicals. They are intended to keep threats away from the wood, and as such, they are considered a pesticide against targeted organisms that consume wood. Now, people tend to get concerned when you start saying words like chemicals and pesticides, but it's really important to have a proper perspective on what's in wood preservatives and why we use them. Organisms that break down wood are relentless, and they are ever present in the environment. Any type of protection must be robust enough to discourage these organisms from deteriorating the wood year after year, decade after decade. Now, pressure-treated wood was originally intended to ensure safety for long-term infrastructure uses, where it's difficult to replace those products. As such, the wood for these uses during the early 20th century was treated under a more is better philosophy when it came to the amount of preservative in the wood. Now, this continued much through the 20th century, and the wood products we made, poles, ties, pilings, and bridges, did exactly what was asked, lasting for many decades in place. Now, while treating has been around for more than a century, the use of treated wood for residential construction is fairly recent. It was first promoted for projects like decks and home use in 1974. And at that time, the chief preservative for these projects was CCA. Now, at the end of the last century, many in the country started taking a hard look at the use, or more aptly, the overuse of chemicals. In wood treating, CCA, which stands for chromated copper arsenate, came under scrutiny. Concerns over arsenate, which is a form of arsenic, led the industry to restrict CCA use, and they don't allow it for residential uses. But there have been no documented health effects to the exposure to CCA treated wood. But here, 20 years later, we still deal with perceptions about poisons in the wood. Today, we really take a much measured approach in wood treating and the use of preservatives, balancing the protection with the need for safe use. Now, it's important to know that all wood preservatives used today are registered with the EPA, and they undergo a regular, rigorous review on their impacts, not only on workers who are working in treating facilities, but also on the environment and those that may be exposed to those. To be approved as a wood preservative, the EPA notes that preservatives must show they can be used without causing unreasonable adverse effects to human health or the environment. And the EPA undergoes re-registration reviews for every preservative every 8 to 10 years and looks at that use to see if it has had any impact on the environment or on human health. So what exactly is in today's preservatives? I think you'll be surprised to know that the active ingredients in wood preservatives are really found in a variety of other products that we use in everyday life. Soluble copper is the main ingredient in waterborne preservatives used to treat the most commonly used preserved wood products in construction. Now, copper is an effective deterrent to decay fungi as well as termites, and has been used for centuries as an antimicrobial. The effectiveness of copper is enhanced with the addition of cooperating biocides and fungicides, and these are intended for some of those organisms that may be a bit tolerant to copper. These include azoles, which are also used in making medicines and products to clean fruits and vegetables. They also include quaternary compounds, which can be found in disinfectants and household cleaning products. We also use borates, which are an inorganic mineral that has great protective qualities against insects. Now, when you're talking about preservatives, the amount of the preservative in the wood is called retention. It's really an important thing to understand when it comes to exposure to these chemicals when you're dealing with preserved wood. Now, retention is measured in PCF, or pounds per cubic foot. Now, a cubic foot of wood would be the equivalent to a 12-foot piece of 2x6 lumber. Now, if it is treated to an above ground use category, or use category 3, with a copper azole preservative, the piece contains 0.06 PCF, or the equivalent of about 1 ounce of active preservative in the entire piece. Now, that same piece, if it's treated to ground contact, is gonna, or a UC4, has a 0.15 PCF, or the equivalent of 2.5 ounces through the entire 12-foot piece. So as you can see, there's really a small amount of active preservative within the piece, but it has a big impact on its protective qualities for that wood. Now, the required retentions or amount of preservative, as well as the penetration requirements for all preservatives, are defined by the American Wood Protection Association, or AWPA. And all these are listed in their annual book of standards that the industry uses in producing preservative-treated wood. And this book lists every preservative that is used within commercial treating today. The effectiveness of these preservatives are also regularly reviewed and assessed through this national consensus process carried out by AWPA. So there are basically two types of wood preservatives used today that are based on the carrier used to move the preservative into the wood. Waterborne preservatives use water to carry them into the wood during pressure treated. These preservatives are essentially mixed with water to carry out the treating process. And these preservatives are found in wood products that are typically used in residential and commercial applications. Oil-type preservatives are dissolved in petroleum products such as diesel or mineral oils, or even biodiesels. And these oil-type preservatives are carried into the wood by these oil solutions. Now, oil-type preservatives are really suited for infrastructure products such as utility poles, rail ties, and pilings, which are used in demanding exposures where maximum protection is required. So let's take a look at the most commonly used waterborne preservatives. Probably the most common available in the marketplace, particularly for residential and commercial construction, are copper azole, or CaC, and micronized copper azole, or MCA. Copper azole, CaC, is used in Western species, and MCA is most typically used in Southern species. The chief difference between these is the size of the copper molecule. And again, based on the differences in the wood fiber, a larger copper molecule works better for Western species, while as the smaller molecule works best in Southern pine. And so you'll see these designations available in the marketplace. One of the oldest waterborne preservatives is ACZA, or ammoniacal copper zinc arsenate. It's also promoted under the brand name Chemonite, and it's been in use since the 1930s. SBX, or DOT, is for the borates, and borates are an inorganic mineral that is very effective against termites and fungal decay. The issue with borates is that it is a water-soluble mineral, so borates are used in applications where there's less chance of exposure to liquid water. Carbon-based preservatives are really the newest line of preservatives, and these carbon-based preservatives don't really use metals like copper, and instead utilize biocides to protect the wood. The key, though, with these carbon-based preservatives is they're not suited for ground contact application. In fact, are not approved for ground contact applications. They can only be used for above ground applications. Another older preservative, ACQ, or alkaline copper quaternary, is available, but its availability has been somewhat limited because the quaternary in that is also used in a variety of different disinfectants. And in the last years, particularly with the pandemic, a lot of that quaternary got moved into disinfectant products, and their availability for use in wood preserving was reduced. So we don't see as much ACQ out in the market as we did prior to the pandemic and even before then. And of course, CCA is a waterborne preservative, and it's still used today. although it's pretty much reserved for uses in agriculture, aquatics, highway, and utility applications. A lot of CCA is used to treat southern pine utility poles. Now for the oil type preservatives, these are for where you need the maximum protection, and these are the oldest preservatives that have been available since the beginning of the pressure treating industry. So they're typically used for commercial and infrastructure applications. Now, out of this list, the 5 on this list, penta or pentachlorophenol is being phased out. There was only one manufacturer for this preservative, and they ended production at the end of 2021. Penta has been used almost exclusively for utility poles. The newest on this list would be DCOI, and the initials DCOI stand for something, but it is one of these long, complicated Latin names that just make it easier to say DCOI. This is coming into the market as a replacement for Penta and for use, again, in infrastructure, which is predominantly utility poles. Creosote is used almost exclusively today in rail ties. And copper naphthenate can be found in not only rail ties, but also utility poles. And IPPC is one that has a small part of the market. It's typically moved using mineral oil into the wood during the treating process. Okay, now let's explore how to specify using the AWPA use category system. Treating standards to balance, they basically work to balance protection and our need for safe use. And about 20 years ago, the use category system was established by AWPA to guide how much preservative should be put in the wood based on its end use. Prior to that, it was done by a commodity basis. So this made it more applicable to the final use of that product. Now, use categories range from UC1 to UC5. The higher the number, the greater the risk of deterioration, and the greater the level of preservative that's needed in the wood to protect against that potential deterioration. So let's go in and look at all of these various use categories. Now, the lowest use category is UC1 and UC2. Now, these are really intended for interior applications. UC1 is for interiors that remain dry, and its protection is really targeted toward protecting against insects. UC2 is very similar, but it may be used on wood products that may be exposed to some dampness. And so the most common product treated to UC2 are sill plates, where the wood may be exposed to moisture from the drying concrete of the footings. Also, UC2 you'll see for framing lumber used in active termite areas, such as Hawaii. In fact, the Hawaiian building codes require that all framing lumber be treated, and UC2 treatments are typically what are used for that, because in framing a home, that's going to be protected against moisture. Now, borate is the most common preservative used for both UC1 and UC2. And the retentions are very similar in both categories, though there are higher retentions under UC2 in areas where the Formosan termite are a risk, which are typically warm and humid climates. Formosan termite is an incredibly destructive insect when it gets into wood, and so that's where additional protection is needed. UC3 are for above ground products. Now, you see there are essentially two major subcategories within this. UC3A is used for wood that is used in the outdoors, but it may be coated or it may be protected from the full effects of the weather. So this would include things like vertical walls or other elements that allow the water to drain off the surface quickly and dry. UC3B is for above ground uses of wood, where it faces the full exposure to the weather. So this would include products such as decking and fencing. There may be some applications where the wood is physically above ground, but it faces similar risks to ground contact. And as you'll see in the next use category, it may be a higher use category may be required based on those conditions. Now, UC4 is considered for ground contact rated wood, and for many, many years, it was fairly easy to differentiate. You got UC4 if you're going to put it into the ground, or if you're going to put it into situations where it may be immersed in fresh water or used in other situations that are favorable to deterioration. But in recent years, the application for UC4 has really evolved a bit, and in fact, the standards under AWPA now note that UC4 is more appropriate to be used in products that may be difficult to maintain, repair, replace, and is critical to the structural performance and safety, or is subject to ground to hazards comparable to ground contact due to climate or artificial or natural processes or construction. For example, let's say you have some wood out and there's a sprinkler system next to it, so it's constantly being exposed to moisture. That may be an appropriate use for a UC4 as opposed to a UC3 rated product. And so it's really up to you as the user to identify what your end use and what the potential risk will be. And this guidance that's in the standards will help you to assess that. Now, I don't have a slide on this, but UC5 is the highest end, and it's really used exclusively for maritime applications, for pilings that are going to be exposed to salt water or fresh water. And there, the protection is really against marine borers who would dig into the wood and deteriorate it that way. We can help you understand these use categories and how to use them in selecting the right preserved wood for common construction applications and exposure. Now, this handy infographic shows the most common uses for preserved wood in residential construction and the proper use category for the expected conditions. And you can go to our website and get more detail, get this infographic and more detail on use categories. Now let's move and talk about preserved wood and the building codes. Now, the International Building Code recognizes the problems inherent in certain applications and the effectiveness of preservative-treated wood in enduring these situations. Now, for some application, the code requires pressure-treated preserved wood. For others, it allows either preserved wood or wood classified as naturally resistant to decay. The most common naturally resistant species would be cedar and redwood. And these contain natural chemicals that are developed as the tree grows that provides that protection. Now, in the IBC, section 2304.12, protection against decay and termites, really details many of the approved uses for preserved wood products in construction. There are also requirements in the International Residential Code, or the IRC, and these are found in section R317, protection of wood and wood-based products against decay. Now, I'm going to focus mostly on the IBC, which has more of the references to specific uses of preserved wood under the code. So in section 2304.12, it defines most of the required uses of preserved wood in specific applications. Now, this would include joists, girders, and subfloors, and wood supported by exterior foundation walls. Additional required uses of preserved wood are found for walls that are below grade, again, that might be in contact with the ground, sleepers and sill plates, which may be exposed to moisture, and wood siding that's less than 6 inches from the ground or 2 inches from concrete. For certain commercial applications, there are requirements for preserved wood in girder ends and in exterior posts and columns, again, where there is a high risk of deterioration because they are exposed to the weather. Balconies, porches, and laminated timbers in some applications, as well as supporting members for permeable floors and roofs, have requirements for using preserved wood as well. And finally, there are, if you're in an area where there's a high risk of termite infestation, the code does have very specific requirements to use preservative-treated wood. And of course, if you're using wood for things like retaining walls, again, where you're basically placing the wood against the ground, there are requirements for use of that. The key is that the ground contact represents the highest risk for deteriorating wood, because ground contact, moisture can settle against the wood and remain there in place through the ground. The ground can also provide a vector for wood-destroying organisms to reach the wood. And so that's why in a lot of these applications, you want to have the level of protection to protect and keep those wood-destroying insects and organisms from impacting the wood. So if you're going to use preserved wood in construction, here are some key things to keep in mind when you go to specify and install those products. Now, preserved wood products sold in retail locations carry an end tag that's affixed to each piece. Now, while these labels may look different based on the manufacturer, they all contain the same building code required elements. Now, these elements include the level of exposure, the exposure condition. They'll include the preservative used, the standard under which the product was manufactured, the minimum retention or the amount of the preservative that's in the product, the identification of the treating plant where that product was produced. And then the trademark of the third-party ALSC inspection agency who inspects to ensure that the quality control meets industry standards. Now, the check mark that you see there signifies that the wood has been produced according to AWPA standards. So only those preservatives that are approved through AWPA can receive the check mark. Now, also on the end tag, if you turn the back of the end tag around, in most cases, you'll find the warranty information for that preservative-treated product. And many manufacturers offer a limited warranty on the products that they sell. Now, a little earlier, I noted that Western species like Doug fir and hem fir that are treated for ground contact, must be incised. And these small slits in the wood allow the preservative to go deep enough to meet industry standards for penetration. Now, the process of incising reduces some of the strength in structural lumber less than 6 inches in thickness. And the amount of the strength reduction is dependent on the size of the wood and the depth and density of the incisions. Now, there are some standard reductions that are in the NDS, or National Design Specification for wood construction, but there are also alternative measures to calculate what that strength reduction could be. In most cases, the treated wood is using a prescriptive approach, and so it's really only when you're using preserved wood in engineered applications where these strength reductions may come into play. On our website, you'll find some more information on incising and the strength adjustments that you may need to make if you are using it in an engineered application. Care should be taken in selecting the appropriate metal fastener for use in preserved wood. And this is because the copper in many preservatives can be corrosive to steel in the fasteners. You get a situation that's called galvanic corrosion, where you've got two different atomic weight metals and then the moisture in the wood provides the conduit, which in the case of copper versus steel, the copper will create corrosion in the fastener itself. So under the building codes and AWPA standards, the following fasteners are required anytime you are building with preservative-treated wood. The most common is high quality, hot dipped galvanized steel, where it has a layer of zinc that becomes a sacrificial layer that protects the steel from interaction with the copper. Stainless steel is another one, and it's often used in marine applications, but it can also be used for more traditional construction. Silicone, bronze, and copper are also out there, but they're these are kind of unique fasteners that aren't often used. Now, the fasteners include nails as well as screws. And so you really need for a long-lasting situation and service life, you want to make sure to use the right fastener. Another important consideration is in field treating. Now, preserved wood products are typically cut and drilled during construction. But as I mentioned earlier, you have a productive barrier that's a shell around it, and not all of the wood receives treatment. And so when you cut and drill them, you can expose parts of the wood that did not receive treatment with preservatives. And the untreated wood can offer opportunities for decay and insects to deteriorate the wood. So one of the most important things you can do to protect the longevity of your preserved wood projects is to field treat all cuts and holes. Both building codes and AWPA require field treating using a treatment containing either copper naphthenate, oxine copper, or the newest formulation is MCQ or micronized copper quaternary. To field treat, you simply clean the surface and then coat or cut the hole liberally so the treatment can soak into the fiber. A standard paintbrush is really all you need for most field treating. Now, we do have a publication on our website that goes through field treating, talks about the code references, and also includes links to the most common field treatments that are available in the marketplace today. Handling preserved wood is really not significantly different from handling untreated wood, and you can safely handle it just using some common sense precautions. For example, the preservatives in the wood may contain substances that cause skin irritation. So when handling, wear long sleeve shirts, long pants, and gloves to protect the skin. Make sure to follow good personal hygiene after handling preserved wood. Wash your hands or any exposed areas after handling, particularly if you're going to be eating, drinking, or using tobacco products. Avoid inhaling sawdust from preserved wood. So use a dust mask for it. And you should probably do most sawing outdoors. And when you do saw, use protective glasses to protect your eyes against flying particles. It is important to dispose preserved wood properly, whether you're dealing with scraps from construction or the removal of preserved wood at the end of its service life. Preserved wood can often be recycled into other uses and other applications. Parks, farms, and residential landscapers often utilize recycled preserved wood for projects. Retired rail ties are probably one of the most common things you see in landscaping, where it's no longer a rail tie, but it still works in gardens and things like that. Do not burn preserved wood in open fires, stoves, fireplaces, or residential boilers, because some of the preservatives that are in that wood can be into the smoke and cause exposure that way. In most cases and in most states, you can dispose of preserved wood in landfills. It's not considered a hazardous waste. The only exception is in California, where there are state laws that have an alternative standards for disposing of preserved wood, and they're allowed in approved landfills. We have a website called twww.disposal.org. TWW stands for Treated Wood Waste, that goes through all the requirements in California for disposing of treated wood encourage you to check that out. Finally, let's talk about best management practices when you're using preservative-treated wood in aquatic or sensitive areas. Now, you'll see preserved wood used in bridges, piers, docks, boardwalks, and buildings that might be over aquatic or wetland areas. And as an industry, we're committed to using preserved wood products in a way that protects against any adverse effects on the environment. And we do that through the Best Management Practices program. Now, the guidelines for BMPs were developed through a consensus process based on research and a core philosophy of minimizing chemical use. Both environmental and economic concerns support the goal of placing enough preservative into the product to provide protection while limiting the amount of preservative available to just the required standard minimum. And this means that there's less preservative available to potentially move into the environment and cause an impact. Now, to help you in using preserved wood and under the BMPs in these sensitive and aquatic environments, we've developed an environmental assessment modeling tool to look at where you can play out any potential impacts based on the conditions that you have for your project. Now, this model is based on extensive scientific research, and it can evaluate risks for preserved wood structures built above, below, or in water. Now, the model covers 11 of the most commonly used preservatives, and you can go in and very specifically define the conditions where that project is going to be, and then from there, look at how the potential impact compared to standards, national or state standards, or other types of regulations. Now, it's important to remember that BMPs are just not off-the-shelf products, and so you know to get a wood treated to the BMP standards may result in longer production time, maybe in an additional cost, and there may be some sourcing constraints in that. So it's important to plan ahead and work with the treater prior to specifying. Now, the material preparation, treatment, and post-treatment procedures and technologies to meet BMPs will vary according to treatment plants and the type of preservative. Though the treatment plant will be the one that decides those procedures, not the specifier themselves. And basically, you just want to make sure that it is treated to the BMP procedures. The treater itself has those prescribed production methods in order to meet the BMP requirements. And then, you know, the BMPs do require both internal quality control and third-party inspection. And so these are all defined under the BMPs that the producers agree to when entering the BMP program. Now, it's important to remember that BMPs represent a shared responsibility with not only the treater, but also those that specify, install, and maintain those products. And there are really 3 steps to ensuring that preserved wood products are produced in compliance with BMPs, particularly for you, the user, and the specifier. You want to make sure to specify the appropriate materials in terms of the preservative and performance as defined in AWPA standards, or if you're in Canada, the Canadian Standards Association or CSA standards. You want to specify that the material must be produced and utilized in compliance with the BMPs. And then, of course, you want to require a third-party inspection agency assurance that the products have been produced in conformance with those standards. Now, when you deal with BMP-produced products, you want to make sure that any order for those products, you want to communicate closely with the treater to make sure that there's a full understanding of what's needed for those products. You want to also make sure that any projects be designed so that as much of the cutting, prefabrication, and framing is performed prior to treating, so that all the surfaces can receive treatment. You don't have openings, as many openings that where untreated wood might be exposed to wood deterioration. The material should be inspected within 10 days of receipt. And if you have problems with it, it's important to immediately contact the treater should you have issues. And should there be concerns about whether the products meet BMP standards, you should withhold that wood from installation and contact the treating company so that can get resolved. In terms of the actual installation, you want to make sure not to do field treating in those places where you do have to do cuts over water and sensitive environments. And you want to try to do that before you get it over there, or have some way to protect it from drips from falling into the environment. Do any cutting, drilling, or sawing at a central station where you can collect the sawdust and trim ends for disposal. Also take care when you're removing an existing structure where you can minimize the potential of debris from that older treated structure that may fall into the environment. And so you want to make sure to collect all that. Okay, for our last section, let's really explore the environmental benefits of treated wood. Now, preserved wood offers many environmental benefits compared to alternative materials. As I've said, wood is really the only construction material made for sustainable, renewable resources. And the application of preservative extends the natural life from years to decades, providing enough time to grow a new tree to become a replacement product. Now, assessing the environmental benefits of any building product really requires a systematic science-based approach, rather than a subjective and sometimes misleading claims that are often promoted. It's really naive to think that other materials are without any risk or impact to the environment. Concrete, steel, and plastic composites all impact the environment in some way. So to help you assess that, the treated industry has used an objective scientific approach to look at treated wood products using life cycle assessments, or LCAs. Now, these LCAs consider the full cradle-to-grave perspective of the products and were conducted according to internationally recognized standards. And they also underwent scientific peer review to confirm the results, and these LCAs have been published in recognized environmental journals. And if you take a look at a qualitative look at treated wood versus alternative materials, you'll see that wood has significantly lower impacts compared to alternative materials. This comparison to borate treated versus steel framing shows that wood has significantly lower environmental impacts in things like greenhouse gas emissions, smog potential, water use, and others. Okay, we've come to the end of our program here, and I just want to touch real quickly on what we've talked about. And I hope you've come away with a better understanding of preserved wood products and why we use them. You know, preserved wood is durable, sustainable, versatile, and environmentally beneficial. These products are uniquely suited for use in demanding conditions where a long service life is required. And this use is guided by building codes, and it is produced under national consensus standards. Now, there are a variety of resources that are available to you to further your understanding of preserved wood. Our website, preservative-wood.org, contains a host of materials that go into more depth than what I'm able to cover this morning. We also have an online library of publications that are available for free download that you can have ready access to when you are working with preservative-treated wood. I'll also mention that we have a sister website, fireresistantwood.org website, for fire-retarded treated wood products. As I mentioned earlier, the process is basically the same, just the solutions you use are different. And we have a host of publications and information on fire-retarded treated wood for use in construction applications. This course this morning was based on some courses we offer online through our eUniversity on both preservative-treated wood. We have courses on fire-retarded treated wood as well. These courses are available through AEC Online as well as Architectural Record, and you can receive CEUs by taking these courses online. And we also offer for smartphones and tablets an app on treated wood to have that information readily available at your fingertips. They're available in the respective app stores for Apple iOS and Google, and just look for Treated Wood Guide and you'll find them there. So with that, I really appreciate your time today. Please reach out if you have any specific questions that I can answer. And I thank you for your time today.
Awesome. Thank you, Butch. All right. We are going to jump into some
Butch, thank you again. First
answers.
question
That came in was related to structural capacity of treated lumber. And this is a question that we get asked at AWC a lot too. Does preservative-treated lumber, does the process of the preservative treatment of lumber have an impact on the structural capacity of the lumber?
No, it does not. The treating will not impact the structural capabilities of the wood. The only case where there is an impact is when it's incised, because the incising puts slits into the wood, and that can reduce certain design values. Fire retardant treating does have an impact on the structural capabilities of the wood. It's because the fire retardants really change some of the chemistry of the wood and do have an impact. And so when you're working with fire retardant treated wood, you do have to make those adjustments, and it depends on the fire retardant that you're using. And fire retardant manufacturers include those design value adjustments in their materials for their specific fire retardant.
Excellent. We had a question on glue laminated treated lumber used in glue lamps. Is that something that you're aware of? Is that being produced, or things like that available for individuals?
Yes, there are glue lamp manufacturers that do offer treated glue lamps. They can be glue lamps can be treated prior to layup, or they can be treated after they've been laid up. So it is possible to do glue lamps and to get treated glue lamps. The one you can also get plywood that is treated as well. One thing you can't get is OSB products, OSB panel products. They cannot be treated for preservative treatment because, as I mentioned, when you're treating the sap wood, which is the outer layer of the wood. With OSB, you're dealing with chips that come from all over the tree, and you don't have a sapwood level like you do with plywood, which where you've got a veneer that might be at the sapwood that can be treated. So you can't do OSB products, but yes, you can do glue lamps, and they are available in the market as treated.
Excellent. I think we've got time for one more question, and we had several people ask this question related to availability. There seems to be some confusion. Is treated Douglas fir available, or is only hem fir being treated currently? Can you comment on that a little bit?
No, both Douglas fir and hem fir are being treated here in the West. What we've seen over the last 25 to 30 years is that production of hem fir has declined over the last few years, whereas Douglas fir has stayed the same or increased, and so we are seeing more Douglas fir being treated just because of the availability of Douglas fir versus hem fir. So it's a little bit more difficult to find hem fir, but Douglas fir is becoming more of the dominant Western species that is available for treating. Again, over the last 3 years with the pandemic, there's a huge surge in demand for treated wood products and all wood products, and we're still kind of catching up from that because treated wood is often used in a lot of DIY projects. And people who stayed at home during the pandemic looked out at their backyard and said, "Oh, we have to do something different out there." A lot of demand came from that, and so the supplies of treated wood have been compared to before the pandemic have been much more limited, and we've really played catch up as an industry over the last few years based on that demand.
Okay. All right, we're just a minute past the top of the hour, but I have one more question I want to ask, just because, again, several people had questions regarding this topic, and I know you addressed it. Can you talk about the use of, specifically we had questions on galvanized fasteners, but maybe expand on that when you're using galvanized nails or other fasteners with treated wood? Or what
Sure.
things should people be aware of?
Yeah, one of the key key things we suggest is if it's shiny, you may have a problem with that fastener because it's probably not galvanized. It's kind of a dull look on it. It's galvanized. The issue is the fact you've got two different atomic weight metals: the copper, which is in the preservative itself, and then the steel. When you do a hot dipped, high quality hot dip galvanizing, you're putting a layer of zinc between the steel and the copper, and that zinc layer provides the protection to keep that from corroding. And so you just want to make sure to use and the building codes and AWPA standards have some specific requirements for that fastener. And we have a sheet on fasteners on our website that details what that is. And even if you're using things like joist hangers, you want to make sure those are galvanized as well, because they're on the surface of the wood. The moisture in the wood creates the connection between the metals that creates that galvanic corrosion. And so, and with a lot of these preservatives, their formulations are 80 to 90 to 95% copper. So there's a lot of copper in that as part of the preservative. So a lot of copper available to have an impact on the fasteners.
Absolutely. All right. Well, thank you so much, Butch. I think we're going to go ahead and give it over to Marcy to close us out. And thank you to all of our attendees for joining us today. We really appreciate your time as well.
Absolutely.
Thank you.
This concludes the American Institute of Architects Continuing Education Systems course. Have a great day.